Okay, let's continue for compound inhibitor analysis. Now we can do some analysis on these inhibitors, this data, see what it looks like. For general characteristics like Lipinski rule of 5, as a molecular weight, hydrogen bond donors, acceptors, and octane water passing coefficient. These coefficients regarding hydrophobic, hydrophilic. This character is for oral drug, is very important for oral drug, whether it works or not in our human bodies. So before we analyze these characters, let's see better background. Why this kind of characters, descriptors are very important in human. So let's beginning anatomy of the human digestive system. This is human digestive. When a drug swallowed from here, oral drug here, swallowed from esophagus to stomach, then to intestine. So the drug food can be absorbed from stomach and intestine. Most of them is there. The stomach, for example, stomach can absorb lipid soluble substance like aspirin and alcohol. Intestine is broadly can absorb the water, lipids, carbohydrates, proteins, bile acids, bile salts, and vitamin. So whatever food or chemicals or drugs inside lumen of the intestine, they are not moved freely. They will be controlled how from the lumen to body. That is a control system for our body control this. So regarding this, the control is regarding the chemical size and polarity is very important, very matter for that. So if you eat drug, the drug can enter your body and working and distribution. At the beginning step, how that can enter the body through stomach or through intestine, you need to know that. So Lipinski's rule indicates that one drug inside lumen of the intestine. Here, see drug inside, how to enter the antibody in body through your vessel circulatory system moving around your body. That is very important. First step important. So Lipinski rule regarding it, first one is size. The size is very important. If from lumen size, the drug size is too big, like a ball, you cannot digest enter your body. So usually control around $500. So that's more optimized size for that. First one. Second one, it's a log P value. It is hydrophobic or hydrophilic. It's balanced. If no hydrophobic, it's hard to antibody. But it must be something between them. Also, the chemical also has hydrogen bond donor, has hydrogen bond acceptor and atoms. Because this part of thing also can affect their permeable cell memory. So also affect absorption distribution around the body. So Lipinski summarize the oral drugs 5 points to see whether it's good oral drug or not. So let's see our compounds, PLRP inhibitors, see which part has so significant correct like Lipinski 5 factors. Okay, so first step we will import data. So we use operating system entering and setting our working directory. So working directory is our folder here. Then we'll import dependency pandas and numpy. After dependent panda, we open the last time we stored data is here. We open data. So the data opened with the compound ID, compound name, SMILE file, target name and active value. So active, we are named with IC50. So in order to characterize of the correct out of the Lipinski value, a Lipinski file rule, we need to reassign data to characterize into three groups: active, inactive, and intermediate. So we use for loop to reassign the inhibitors to three groups. If in bioactive class is empty list, then in every item inside of active value, if bigger than 6 micromolars, we append them with inactive. If I6 is less than 6 nanomole or 0.006 micromolars, so we set active. Between these, we set intermediates. So if we run that, we see a lot of active and inactive. So sometimes people will ask how you can choose which one is the limit value, which one is active, which one non-active, because we have 3,600 chemicals here. So for my part, I think I need to dissect difference between inactive and active. I want to find some fingerprints which maybe contribute more for active drug. So so I choose 6 and 0.6 to divide them. Principle, we can think the choose the value depends on your data distribution. Because we have 3,600 chemicals, so I think this is normal distribution pattern. So this part, I think, is active parts. So it's I choose this part. That will compare with this inactive compounds parts. The middle, most of them is intermediate. So I choose 6 micromolar. It is inactive, cover this part, and 0.006 micromolars it covers this part, is active part. In middle part, it is mixed both characters. So I don't want to compare. I want to compare 2 points, end part and front part. So that will tell me which signaling structure changed or associated with active or non-active. So my purpose is this. And also I want to put the 2 parts of the number be balanced, because the balanced data will be good for machine learning model establishment. So in my part, if I choose my value, I can get 489 compound is active and 510 compounds are inactive. Most of them in between is 2,601 is intermediate. So this part I can choose for that for my further analysis. So I choose the compound range around here. It's good for me for further process. So I choose here. For your project, according to your data, you can change it to compare inactive and active based on your value. Because with the time, if more and more compounds found entering the library, you may adjust the volume to find the right position to compare how to the structure, similarity or dissimilarity. Okay, that's my part. I choose that. So when the data was assigned to intermediate, active, inactive, you will see the data will be updated in the frame. The type so it is list data, and we combined by active data inside the column. So by active data class already here, and be assigned active, active, active. Some is inactive, inactive, inactive. Original assigned is not correct. I don't use that. Just give me a suggestion because it's literature. For my experiment, for my data frame handling, I need a new assigned active, non-active values. So let me check. My data looks like by active class column to unique, you can find the three parameters: active, intermediate, and inactive. So let's count using by active value count exactly how many data for each category, how many rows. You see, inactive is 510, active is 489. So let's start this data, raw data. Open again. I will say to doing some analysis for Lipinski. So based on active and non-active two categories. So whether these two categories, active with inactive, has this completely different of molecular weight, hydrogen donors, hydrogen donor, hydrogen bond acceptors. So let me check this. We for Python we use a function we call Lipinski to dissect to get the data inside. For this Python code, say use function data. Function is Lipinski. We use smiles as input file. Verbals between when the computer process data, I don't want to say any information output. Just say finish, finish. Let's see the final results. Intermediate process, we don't want to see that. At the beginning, give empty molecule data data list, empty data frame data. So and at the beginning of running, in each item, each element in the smiles, like this smiles, each item in smiles, it will be handled uh, by molecule from smile to extract the molecule information. After information was abstract, then put the data list. This is we give empty data frame. Later on we put data inside the data frame. For molecular inside the molecular data here, so there will be dissect to see molecular weight, log P, number of donors, number of acceptors. So that's it is function dissection to see how the molecular character looks like. Later on, we use each molecular we give a row to showing molecular weight, log P, donors, acceptors. So this is one dimension for at the beginning we one dimension to see several character of the molecule. Later on, we stack. It's with vertical stack the data according to row. Put each means each row represent one molecule, and each column represent by molecular weight, log P, donors, acceptors. So if data finish running like that, the function works final result like this. Each row has each represent of one molecular, column represented by molecular weight, log P, number donors, number acceptors. So this is running by the function of Lipinski function. This code is running very well to dissect the character for Lipinski rule for 5 for each molecule. So after we got the data, we combine the original data frame and Lipinski data, new data, put together. So we combine together using PD count to combine the two data frames. So two data frames updated to found here, molecular weight and log P, everything will combined added together. Number of hydrogen bond accepted donors. Okay, that's the Lipinski file rule of data we got. So for you can check for columns, confirmed columns. We have new columns add. Because we now have characterized inactive and active compounds. We need these two categories. But we want to know in each category for how the activity looks like using a PIC50 value. PIC50 is transformation of our originally active value micromolar transformed. So that is make the data distribution is not too broadly. So for example, concentration maybe is 0.00009 micromolars. That is too small. Someone is too big. It's very data. So if you give a log transformation, maybe only become 10 for 5.9. So the value is small. It's just transformed for another distribution, another format. This is good for handle, good for statistics. So before transformation, we give re-engineer some data for normal because some data is too big. For example, here, too big like this. This data is outlier, it's too big. This one is 8,000. This one is very high 8,000. So we want the data be inactive, so we kept that. Anyone if beyond 9,000, that be 9,000. We don't want to record anyone from very high this value. Okay, so let me see 9,000 micromolars. Already inactive, we want to see kept the value. So if anyone over 9,000, we called 9,000. Then give the back list. So we put the list, give a new this normal value, give a new form, new column is called standard value of normal. It's capitalized. So after get capitalized, we drop the original active value because it's reassigned to drop. Original active value is kept. The big value will be kept. So here the original value is dropped. So PRPC50, the standard normal value will be incorporated, replace them here. This is standard value. So 9,000 is it will kept here. That's the original data here, but this one was now assigned to new value as capital maximum value here. Okay, after this we can do some PRC50 transformation. Is the code for function code to transform of the value to IC50 PRC50. Here is an empty list here. Then we use a standard value normally to handle this data. Before that, we can to transform micromolar concentration chemical to molar. Here this is change format -6. Here we use npi log function 10 to handle process the original data, molar data to to rearrange the data range. So thus data is become smaller and compact. So we put all data in the list. Finally, using this data frame, add a new data frame we call PRC50 using PRC50 value. Finally, we dropped standard value or a standard volume column. Then we incorporate with PRC50 column. Return X. X it is was the original data will be changed to be replaced. So X is returned to replace original input. So after incorporate PRC50 value, so we can know new column showing here, PRC50 here. Okay. So this data is important for us to compare our inactive and active two groups. That tell us how the active group, the activity, and the inactive group activity. So that's running for the save data. Okay, we can use two CSV to save our data is raw data. So let's check the PRC50 volume is from 10 to 2. Okay, say inactive is on the 2, active is top one is 10. So big difference. Still compare to save data. Save data. After save data, we beginning to handle pick up two groups, active and non-active. We called two class. In final data, we're using by activity group, by ID group here. Have active and inactive and intermediates. We pick up we only pick up active and non-active jobs intermediate. So we just choose our two category after running. So this class only has active and inactive. Based on two group compounds, we can compare how Lipinski rule of 5 characters on the two groups compound. See, let's beginning to using Seaborn metabolic poly library to draw the data. So import Seaborn and CS metabolic library using PLT, PyPlot as PLT to analyze the drug. So we use field function to at the size of 4.5 to x 4.5, and choose x is with using by activity class column, which has active inactive two groups, and data is from the df2 class. Then we x level of by activity and the frequency. So if running, you see active group and inactive almost similar frequency. That's we choose for value to limit value to limit the two parts, endpoint and here from part and endpoint, inactive, non-active. That is we try to choose two groups to compare. After choose that, we can compare correct of two group compound according to molecular weight, LOX-P, hydrogen bond donors, and acceptors. Say here is choose molecular way. The function choose x, y, choose x molecular way and logs p. So we all use a different labeling by activity class and size labeling of PRC 50. So all the characters will be labeled on page. So let's running for this. After running, you will see after running you will see this is code running. You will see that fixed size. So for activity, it labeled with blue. Inactivity with around orange color here, and size. If PRC 50 smaller, its size is smaller, it's just activity low. The bigger is active higher. So according to this overall picture show two groups, active and inactive. Most of them is overlap. For looks higher log speed, hydrophobic higher. If hydrophobic higher, log speed higher, very higher, it is could be inactive. And looks and molecular weight increase could be higher activity. However, as we said, most good drugs are around 500, around this area. So from molecular weight is on here. So this correct. We cannot direct design according to this. We want to find this group inactive and this activity group inside. What's the significance different? We can use a fingerprint to find some substructure, maybe contribute to activity, the activity. Okay, so we ask whether the activity, what looks activity distribution look like. So let's see, PIC 50 value, what look like activity on two groups. Here, this could show this is activity using PIC 50 value is very high. It is inactive. See, that is two categories. Inactive and active has significant spread of activity according to PIC 50 value. However, you using size or using log P or the molecular weight cannot distinguish two groups like that. So that gives us a chance. We can, if we find a fingerprint inside this and inside this, can contribute so significant difference, so big difference, that's valuable for your design new drugs. So that's what we're looking for. But the Lipinski value correct not contribute like so significant, so obviously. So let's in details to follow to see details what looks hydrogen donor acceptor, hydrogen donor acceptor acceptors, what the contribution look like. So we need using statistical model, statistical method to determine two groups has significant, whether has significant difference. So here you U test, which is the non-parametric statistical significance test, because we categorize the compound as two groups. One is active, one is inactive. So that only can be used U test, cannot be T test. So function group is function code. You can find here, from the website. This machine learning mastery here company here. So you use a U test. So this you can use code for your own project test. Okay, you can download or copy from here. So I don't need to explain details. This dependence for import. And the first one, select active group, for example here. Then second part, choose inactive group. Then we can compare with the U-test, compare active and inactive. The data should compare with cut value is 0.05. If anything, p-value bigger than 0.05, we say no significance. If p-value smaller than 0.05, we say significance. Significance is rejected. H0, hypothesis 0 is for statistical reason, H0. But for your details, you can read that for this kind of method. For me, I just show you my results. See here. I show U-test for PRC50 based on activity group and inactive group is significantly different. From our side, it's significant. From the U-test, it's significant. That's interesting. That's our base for continuous project. Otherwise, we cannot continue go forward. Okay, let's say test for molecular weight was significant. So here showing choose by activity to inactive and active two groups, and why we choose column as molecular weight. So we'll see that active groups molecular weight, some part is bigger than this, and inactive group molecular weight is smaller. So it's similar as here. Here, right? Statistic data showing when I size here is similar results. How about the log p? This log p on y axis we choose the column here. X is also by active class two groups, active inactive. So we compare two groups, see log p was different, hydrophobic and hydrophilic. So overall, you see average is similar, and the inactive looks higher, has higher hydrophobic log p value, hydrophobic. It's suggesting if the drug is designed with less hydrophobic or the strong higher hydrophilic character, maybe help for activity design. But overall looks similar, although maybe contributed. But I want to see some dramatic effect on these different groups, the fingerprint, something like that. So we definitely know substructure contribution to activity like this. Big difference between two groups. So we hope inside something it can be found contribute to this, not something molecular weight and log p. So contributing to that. So it leaves the contribution, not too many. And also number of donors and the number of acceptors, 100 acceptors, 100 bound acceptors. Say similar coding program, just choose different parameters to compare based on inactive and active group. Say both showing significant difference, but average close, suggesting couldn't contribute to the desired effect like this activity. So that is desired effect. We want to see that. I want to dissect the mechanism why some structure, maybe substructure, maybe contributed activity different. So that gives a chance to continue the project. Okay, today I'm just showing some background knowledge of the Lipinski file rule and some code regarding how to extract Lipinski character based on two category compounds, active and inactive. So after that, we will continue for fingerprint extraction to design drugs. Okay, thank you.